Hey everybody, we're live and in stereo. So today, my dears, the deers, deers, right? So today, my dears, we are gonna start off with a beautiful concept of dilution in Mohs and stoichiometry, and this is already a part of your O-level course, but we've never been taught it in such a detail that is required in A levels, right? So I'm gonna teach you dilution, but before we do that, let me just quickly do another question that we did we did all the advanced questions for stoichiometry in the last class, and all the other questions will be uploaded onto your portals, the limiting and excess one and everything, right? Because it's largely O levels and IGCC. The difficult ones, I did it with you. But before we start dilution, I want you guys to quickly solve this question for me. The mixing of solutions, that's what I call it. The mixing of solutions. And we did a lot of questions in the last class for mixing of solutions, right? For example, you have like calcium nitrate solution, and the concentration of this calcium nitrate solution is about like 0.1 molar, which is 0.1 mole per dm cube. That's just a fancy way of saying mole per dm cube, an easier way effectively. And you have volume, which is about, let's suppose, 50 cm cube of this solution, right? The volume of this solution is 50 cm cube. And then you mix it with another solution, which is sodium nitrate solution right here. And the concentration of sodium nitrate solution is, let's suppose, 0.5 molar, which is a fancy way of saying 0.5 mole per dm cube, and the volume of this solution is, let's suppose, 40 cm cube. What is the question is what is the concentration of nitrate ions when you mix these two solutions, when solutions mixed? And it's pretty simple. How did we solve it? We learned the entire logic behind it, and the way we solved it was, hey, I need nitrate, but I'm given what? I'm given sodium nitrate and I'm given calcium nitrate, which means I need to have a balanced equation. I need to have an equation connecting calcium nitrate to the nitrate ions, connecting sodium nitrate to the nitrate ions, and we already know it. You know that if you have calcium nitrate aqueous, how many calcium ions do you have? You have one calcium ion, and for every one calcium ion, you have two nitrate ions. That's true. See, for every one calcium ion, you have two nitrate ions, right? So that's the equation for it. That's the equation, sir. And what about sodium nitrate? For every one sodium ion, you have one nitrate ion. So if it's an aqueous solution, you have the sodium ion and the nitrate ion, right? So what we do is, what were our steps, or the steps that we learned? The step number one was to find the moles of nitrates in individual solutions, right? So what we do is, we used our relationships to jump from calcium nitrate to nitrate moles. We jump from sodium nitrates moles to the moles of nitrates, right? So we find the moles of nitrates individually in both solutions, and then when we mix them, we add the moles, we add the volumes, and sir, we end up with concentration by using N equals CV. And this V is the total volume of the resulting solution, the resulting mixture, which is 40 plus 50. And these moles are the total moles, the sum of these moles and the sum of these moles. So how do we do it? Please do it for me. Sir, we need to go from this data into the moles of calcium nitrate, because you can go from the moles of calcium nitrate into the moles of nitrate ions, right? So how do we do this? So first step, calcium nitrate is given to us, said, and we want to figure out the moles of nitrate ions. So first, find out the moles of calcium nitrate, which is, he's given you the concentration with 0.1 molar and the volume. So N equals CV. He's given me concentration, which is 0.1. Volume is 50, but divided by 1000 because it's in cm cube. You want to convert it in dm cube because concentration is in mole per dm cube. So what do we get? 0.1 into 50 divided by 1000. 0.1 into 50 divided by 1000. You get, sir, 5 into 10 raised to the power minus 3 moles. And these are the moles of calcium nitrate, sir. Now I don't need the moles of calcium nitrate. I am required the concentration of nitrate ions. So I need the moles of nitrate ions. How do you go from calcium nitrate into the moles of nitrate ions, sir? It's pretty simple. You know that for every 1 mole of calcium nitrate, you have 2 moles of nitrate ions. Sir, how do I know this? See, it's even evident from this. 1 mole of calcium nitrate has 2 nitrate ions. And you could even look at the equation. 1 mole of calcium nitrate has 2 nitrate ions, 2 moles of nitrate ions. So, if you have 5 into 10 raised to the power minus 3 moles of calcium nitrate, how many nitrate ions do you have? N cross multiply. It's twice the number, right? So, it's 0.01. So, these are the moles of nitrate ions in the first solution. Now figure out the moles of nitrate ions in the second solution, which is sodium nitrate solution, right? Find the moles of nitrate ions, sir. N is equal to CV. And I know that the moles of sodium nitrate that you're gonna have are gonna be the same moles for nitrate ions as well. Why? Because it's 1:1. For every 1 mole of sodium nitrate, you have 1 mole of nitrate ions, right? So N is equal to CV. What's the concentration? Is 0.5 and the volume is 40. So concentration is 0.5, volume is 40 divided by 1000. Why? Because it's in cm cube. I wanted to convert it in dm cube. 0.5 times 40 divided by 1000. What do I get? I get 0.02 moles of sodium nitrate. And I know I don't want sodium nitrate. I just want the moles of nitrate ions. And I know if I were to compare the two, I know that for every 1 mole of sodium nitrate, you have 1 mole of nitrate ions. So if you have 0.02 moles of sodium nitrate, how many nitrate ions moles do you have? And cross multiply, you get 0.02 moles. Done of nitrate ions. Now you have the moles of nitrate ions. These are the moles of nitrate ions in the second solution. These are the moles of nitrate ions in the first solution. So what do? I find the total moles because now I'm mixing them. So what are the total moles of nitrate ions? 0.01 plus 0.02. These are the total moles of nitrate ions, 0.02 plus 0.01. I get 0.03. These are the total moles of nitrate ions. Once you mixed them, these are the total moles of nitrate ions that you're going to end up with because you've mixed solution 1 moles and solution 2 moles. And how much volume do you have? So you had 50 cm cube from the first one and 40 from the other. So when you mix them, a total volume total, which is what? 50 plus 40. It's basic math. That is 90 cm cube. And now you have the volume of the mixture, you have the moles of nitrate ions in that mixture, and you could find the concentration, N equals CV. You have the moles, 0.03, volume is 90. Let's suppose I want it in dm cube because I want the concentration in mole per dm cube divided by 1000. C is equal to 0.03 divided by 90 over 1000 is what? It's 0.09. So what's the concentration? See, this is mole. And now this is dm cube. I converted it into dm cube. 90 divided by 1000 dm cube. 0.03 divided by 0.09. 0.03 divided by 0.09. Done. What do we get? 0.333 mole per dm cube. That's the concentration of nitrate ions in the mixture. I hope this concept is crystal clear. Crystal like the day. Done. So this, we already did so many questions for this concept. I can't stress more on this. It's always tested. And we did a couple of other stoichiometry advanced questions that a lot of teachers don't cover because frankly speaking, I don't want to say anything bad, but I don't want to say anything. Chalo. Today, we're going to cover the concept of dilution. Now, dilution of solutions. Dilution of solutions. That's the last concept of moles and stoichiometry, and you guys have to watch all the other concepts, which is limiting and excess, percentage composition by mass, percentage yield. It'll all be available on your portal. All done. And from probably on Saturday or Sunday, I'll teach states of matter. It's a 1-day chapter, and then we're done. Then we just left with 3 more chapters, and then we start off with organic chemistry. Done? Okay. Now, dilution of solutions. What do we mean by this? Well, let's suppose I'll explain it through an example. Let's suppose you have this beautiful beaker right here, and it has like sodium hydroxide. Done. This beaker has sodium hydroxide, and the volume of this solution is 50 cm cube. It has a solution of sodium hydroxide. Maybe you want to make soap, and it has 50 cm cube of sodium hydroxide of this solution. And the concentration of sodium hydroxide that you have is 0.4 mole per dm cube. 0.4 mole per dm cube or 0.4 molar. That's my solution right here. Now, I want to do some milawat, just like they do in milk. If you go to the Gujjar or the milkman, what they do is they take milk and they add water in it. They do milawat. That's called dilution. That dilution. You have a solution with a certain concentration. You have a solution with certain concentration and you add water to it. Resulting in what? Resulting in diluting that solution. It has a beautiful concentration, and what I am going to do is I'm going to add water to it, just like Gujjars do. Just like Gujjars add water to milk. Similarly, I'm going to add water right here. So what am I going to do? Let's suppose I add 200 centimeter cube of water to it. 200 centimeter cube of water to it. And I'm going to end up with a resultant solution. Now the question is, what's the concentration now? What's the concentration of sodium hydroxide now? What's the diluted concentration? There are multiple ways to ask this question. What's the diluted concentration of sodium hydroxide? What is it? Well, before I talk about the dilution, can you guys tell me how much volume would you have at the end? How much volume would you have at the end? How much volume, sir? How much volume would you have of the solution? It was already 50 cm cube of solution. You added 200 centimeter cube of water. How much volume do you have? It's a pretty mathematical question, I guess. I think it's not rocket science. I think you'll have 250 cm cube of water. Why? Because you already had 50 cm cube. You added more water to it, right? Now the question is, what is the concentration? What do you do for concentration? My question. What do you do in order to figure out concentration? In order to figure out concentration of any solution, you have this formula N equals CV. And what that means is you need the moles of that particular substance in that solution. You need the volume of the solution, and you can therefore find the concentration. And we've actually derived these formulas back in the day, right? We've done a lot of questions. But now we know in order to find any concentration of any particular solution, I need to take the moles of that solution, I need to have the volume of that solution, and I can find concentration. Simple, right? It's just a mathematical equation. Now, my question to you guys is, do I have the volume? Do I have the volume? Absolutely, I do. I have the total volume of this solution, which is 250 cm cube. So that's one tick mark. Do I have the concentration? No, I have to find the concentration. What else do I need? I need the moles. I need the moles. How in the world can I end up with the moles? From this data. Before diluting it, you have the moles right here. What's the moles? You're given the volume. You're given the concentration. N equals CV. Sir, how many moles of this solution do you have? N equals concentration is what? 0.4 molar into volume of this solution is 50 divided by 1000 because you want it in dm cube. Moles of this solution. What do you get? How many moles of this solution do you have? Anji, 0.4 times 50 divided by 1000. Sir, Anji, somebody help me out. Should I do it on my own? I'll do it on my own. Nobody wants to help me. Okay, now you guys are answering. 0.02. So 0.02 are the moles of sodium hydroxide. Now I have the moles right here. And what am I going to do? I'll just plug the moles right here. So N equals CV. I have the moles now, which is 0.02. Before diluting it, concentration I need to find. Volume of this solution is 250 divided by 1000 because it's in cm cube. And what do you get? Concentration equals 0.02 divided by 250 divided by 1000. What do you get? 0.25. 0.25. And what in the world do we end up with? 0.02 divided by 0.25, 0.08. 0.08 mole per dm cube. That's the concentration of the resulting solution. Oops, what happened? Can everybody see it on the screen? Nobody? Wait. Yes, now it's fine. It just disappeared from the screen for some reason. So that's the concentration. It's pretty basic, huh? It's pretty simple. This is what the concept of dilution is. Now, fun fact, I've also taught this in O-levels, but not by the name of dilution. Do you know how I've taught this in O-levels? And please, I'm going to teach you a formula right now. You don't need to know that formula, but can you guys see it now? Can you guys see my screen now? It disappeared, I know, but is it back now? I think it's back. It's back. It's back. Okay, okay. Something goes wrong with the bunkers with the amp from time to time. Now, please listen to this very carefully. If you've studied O-levels from me, I've taught you this already. Remember, in O-levels, in ATP, this question used to be tested in alternative to practical. Remember when we used to have a particular question in which what used to happen was I would have a certain concentration and I would have a certain volume, and then I would add more water to it. I would make up a bigger solution. I'd add more water to it, right? And when I'd add more water to it, remember what we used to do? We used to say, hey, the moles that you've calculated right here, N is equal to CV, the moles don't change. even after you add water, the concentration can go up and down, but the moles don't change. The moles of sodium hydroxide that you've added initially would remain the same. The concentration can change, but the moles doesn't change. And remember, do you guys remember what example I used to give you? I used to give you the example of ruhafza. I used to give you the example of juices, of tang. What did I used to say? I used to say, hey, you guys have a cup of tang. You guys have a cup of water. Let's suppose cup of 50 cm cube of water. Let's suppose. And I add 2 tablespoons of ruhafza to it. Raima, do you remember this? You used to add 2 tablespoons of ruhafza to this, or 2 tablespoons of your favorite juice to it. Right? Tang to it, let's suppose. And now what I'm doing is, because the guests have come over and I'm a big miser, I don't want them to finish off my ruhafza. So what I do is, instead of adding more tablespoons of ruhafza, or instead of adding more tablespoon of juice to it, ruhafza is basically a liquid juice that we add in our water for those who are listening to this outside the Desi community. So instead of adding more tablespoons of ruhafza, do you know what I did? I add more water to it. So now the resulting solution is about 150 cm cube. But my question to you guys is, have the tablespoons of ruhafza changed? Have the tablespoons of ruhafza changed, sir? Is it the same 2 tablespoons or no? Sir, I did it in this way. Is it the 2 tablespoons? Absolutely, the 2 tablespoons remain the same. I have not added more tablespoons. So these 2 tablespoons are like moles, sir. These 2 tablespoons are what? Like moles. If you add 0.02 moles of sodium hydroxide if you have 0.02 moles of sodium hydroxide in a solution, even if you add more water to it, the moles will remain the same. The concentration will go up and down. Yes, that's true. I believe you. But the moles will remain the same. Now, listen to this. That's the reason why I said to calculate the moles here. And you could use these moles in this particular equation. Why? Because you know from the moles remain the same in dilution. You add more water to it, doesn't matter. The tablespoons of ruhafza are the same. I have not added more moles. I've just added more water. The moles are the same. The concentration can go up and down, but the moles are the same. So what does that mean? What does that mean? What does that mean? That means that you can derive something. Can I say that moles before dilution, N is equal to CV, right? This is how I found the moles right here before dilution. Let's suppose this is my concentration 1 and this is my concentration, this is my volume 1, right? Then in the second case, and in O-levels you weren't required to know these formulas. That's why I used to teach it like this in O-levels. Remember? I used to teach it like this in O-levels. Just simple logic. I never used to use the fancy term of dilution. Now, okay. So N equals CV. And then here N equals, this is my second concentration and my second total volume, right? The final volume. The question is, are these 2 moles the same? The moles before dilution and the moles after dilution, aren't they the same, sir? Aren't they the same? Are they the same? And you could use basic math for it. It's basic math. If the moles before dilution are equal to the moles of after dilution, can I say that this N will be equal to C1V1? Can I say this? Because N equals C1V1. So instead of this N, can I write C1V1 here? And is C1V1 going to be equal to C2V2? Absolutely. That's how this formula might have been taught to some of you guys in O-levels and IGCSE, but it is not the requirement to know this formula in O-levels and IGCSE. The examiner does not require you to know this formula. This is the formula for diluting anything. But because I'm Sir Suleiman, instead of just teaching you guys the formula for diluting anything, I wanted to give you guys the concept, which is what? Which is, you need to understand that you could equate these 2 equations together, since the moles before dilution and the moles after dilution are the same. And the reason for that is this simple idea. If you have 2 tablespoons, if you add 2 tablespoons of liquid to some water, it'll still remain 2 tablespoons even after you add more water to it. It'll get diluted, but the ruhafza quantity, the 2 tablespoon would be 2 tablespoon. Right? Makes sense, guys? Yeah. So that's the basic concept of dilution. Now, my question to you guys is pretty simple. If you were to do it directly, how would I do it directly? See, you have 0.4 mole per dm cube. This is my C1. That's my V1. And this is my C2, this is my V2, and I need to find C2. So I can directly equate it. C1 into V1, which is 50, equals C2 into V2, which is what? V2 is 250. What do you get, sir? C2 equals 0.4 into 50 divided by 250. What do we get, sir? 0.4 into 50 divided by 250. I get 0.08 mole per dm cube. But sir, you did not convert them into dm cube. Why? Why didn't you convert this first into dm cube and find out? Because understand, guys, the only reason why you converted it because you want this dm cube to cancel out with this dm cube. That's why you convert it, right? But in this case, you can even work with cm cubes because see, you have 50 cm cube at the top, you have 250 cm cube at the bottom. This cm cube and cm cube cuts out. So you get 0.4 times 50 divided by 250. No need to convert it into dm cube. You can still add dm cube at the end because concentration was what? It was in mole per dm cube, right? This was the concentration. So cm cube cuts out. The remaining concentration is also going to be in mole per dm cube. Pretty simple, huh? Yeah, no, Raima. And please, I've never said that. I said that the moles before are equal to the moles after. It's the same. So you can equate C1V1, which would be equal to C2V2. That's what I said. Because the moles before and after are equal. I'm just replacing this N with C1V1. And if you don't get this formula, it's fine. You can use the same method, which is what? First calculate the moles, and after diluting it, you have this as the total volume, and the moles would remain the same because 2 tablespoons of Ruh Afza before adding more water and 2 tablespoons of Ruh Afza after adding more water is the same thing. Ruh Afza tablespoon remain the same. Now, my question you guys is to calculate just a couple more questions and we're done with this concept. Maza aa raha hai? Are you guys enjoying moles and stoichiometry? And you love it after you go over limiting and excess and all of those videos, please. I want you guys to go over it. So don't be bamboozled by these different formulas. It's the same concept. Same. Okay. Hi. Okay. Now, my question to you guys is, you had a beautiful solution of maybe 2 mole per dm cube of HCl, and it had a volume of 50 cm cube, right? Had a volume of 50 cm cube. Now, you knew that as a lab assistant, you guys knew that this is highly concentrated. It's a very concentrated solution of HCl. You knew that students can get, if it comes into contact with students, it might even harm their skin, irritate them. You're trying to dilute it. So what you do, this is what lab assistants do. They add about, let's suppose I add about 100 cm cube of water to it. 100 cm cube of water to it. What's the concentration? Hanji, shabash, of HCl. Now you guys can use the trick quickly, the concept. It's not even a trick. You know the idea that the moles before and the moles after remain the same, right? So if I were to calculate moles here, N is equal to CV, C1V1, that would be equal to N is equal to C2V2. These moles are equal. So I can equate them. I can say, hey, C1V1 equals C2V2, right? That's the formula for dilution. So what is C1? It's 2. What is V1? It's 50. Concentration 2. Volume 2. What is volume 2? It's not 100. Please, it's not 100. It's the total volume. 100 plus 50. 100 plus 50. It's the final volume of this solution, which is 150 cm cube. Not 100. Please, it's not 100. So it's 150. C2 equals 2 times 50 divided by 150. What do we get, sir? Hanji? Aisha, I'll go for your word. Aisha is saying 0.667 mole per dm cube. Why is Aisha using mole per dm cube? Shouldn't it be cm cube? No, sir. See, I'll even prove it to you. This was 2 mole per dm cube multiplied by 50 cm cube divided by 150 cm cube. So cm cube and cm cube cuts out. The final volume, the final concentration is again in mole per dm cube. Done? Okay, good stuff. But, and it's quite diluted now. But what if the Cambridge examiner told you, hold up, you are a lab assistant, and dumb assistant. No, I'm joking. This HCl was still 0.2 mole per dm cube, and the volume was 50 cm cube, obviously. And the examiner said, wait a moment, can you guys dilute it? You know, they tell you to dilute it to 0.1 mole per dm cube. Dilute it in such a way, dilute and also write per dm cube like this. Dilute it in such a way that the concentration of HCl becomes 0.1 mole per dm cube. How much water do I add? This is the question. How much water should the lab assistant add? Hanji. See, now it will all make sense to you. And you guys can actually calculate it through the original method from O-levels and IGCSE. First find the moles here. Once you calculate the moles from N is equal to CV, then you know the moles before and after dilution would stay the same. And so N is equal to CV here, and you'd end up with volume. Can somebody calculate it, please? And here is where you'll all make a mistake. I know. Most of you are. So let's just quickly go over them. That's why I want you guys to calculate it. Aisha is saying add 950 cm cube of water. Let's see if Aisha has made a mistake or if she's correct. Right? Aisha is in fact correct. Aisha is awesome. Some of you write, yes, yeah, this is what I wanted to catch. Yahya is saying, sir, 1000 cm cube. This is the mistake I wanted to catch. So Aisha was pretty smart about it. Aisha said, hold up, sir. You said the way you dilute it is C1V1 equals C2V2. And we know the reason for it. Why is this the reason? I told you the reason for it. Because the moles before this would be equal to the moles after this. So N equals CV, N equals CV. You just substitute the C1V1 and C2V2, right? So, Aisha said, hey, sir, you have 2 mole per dm cube here, you have 50 cm cube here. The concentration I need is 0.1. Volume, I don't know, right? So what do you get? 2 into 50 divided by 0.1. And this is the mistake what Yahya made. Yahya said, sir, the answer that you get, what is X? X equals, or the volume that you have, why am I calling it X? I should call it V2. The volume that you have, V2, that you end up with. And this is going to be a pain in the neck, but it's fine. Is 1000. And Yahya said the same. And this is the correct answer. No, you Dumbo Jumbo. This is not the correct answer. Why? Because the question was not what's the final volume of the solution. This 1000 cm cube is the final volume of the solution. The question was how much should I add? Look at this. This 150 cm cube, and that's why I did these couple of examples, because this 150 cm cube, this V2 is not how much water you are adding. This V2 is the final volume of this solution. This V2 is not how much water you're adding, it's the final volume of this solution. How much water did I add? 150 minus 50, 100. So, this 1000 is the final volume of this solution. It's the final volume. But what was the initial volume? The initial was 50. Yeah. Remember, initially you had 50 cm cube. Now final, you have 1000. So how much water did you actually add? Yeah, it's 1000 minus 50. I added 950 cm cube of volume of water to it. Why? The reason why I added 950 is because once you add 950 plus 50 is 1000. Yeah, this is what we've been doing up until now. See, you had 100 cm cube of water being added. You weren't saying V2 is equal to 100. You were saying the final volume of the solution is 150, 100 plus 50, right? 100 plus 50. Here, look at this. 200 plus 50. That was the final volume of the solution. So this is the mistake I wanted to catch, which is some students don't try to understand this, that this V2 is the final volume of the solution. It's not how much volume of water you've added, it's the final volume of the solution. Want to do one more question? 1? How do you get 1, Naima? How do you get 1? I'm sorry, but how do you get 1? The calculation ka masla hai, I don't know. 2 times 50 divided by 0.1, I think. 1 dm cube. Oh, don't convert it into dm cube, Raima. It's cm cube. I don't like dm cube. Done? So it's not 1000, but it's not 1000 centimeter cube. That's the final volume of the solution. 1000 cm cube is the final volume of the solution, or 1 dm cube is the final volume of the solution. I don't want the final volume. I asked you how much water did I add? How much water do you need to add to dilute it this much? It's 950. Because 50 is already there. It's like the V final or V total or V2. Right? You could even write it like, if you are into rote learning, it's like the V total is the initial volume, which was what? Which was 50. The initial volume plus the volume of water. And so this is actually 1000 cm cube. This 1000 cm cube is what? The initial volume plus the volume of water that you added. Another question. Here's a question from a book. It's not from a book, it's from my brain actually. But in the books, such questions are tested. Okay? Let me ask it. Okay. So, you have you add 30 cm cube of water. Now, enough of visualization. Now, no more visualization. Now, I'm just adding 30 cm cube of water to 4.50 mole per dm cube and 125 cm cube to 125 cm cube of 4.50 mole per dm cube of barium bromide solution, right? Aqueous. Question, listen to this. What is the final concentration of the solution? What is the final concentration after adding the water, 30 cm cube of water? Now do it. Shabash. What is the final concentration of the solution? Concentration, please. And I want the final concentration in let's say mole per dm cube. I want to make these concepts as clear as possible. See, we know it's dilution. I'm adding 30 cm cube of water, 30 cm cube of water. So C1 V1 equals C2 V2. And we know why we're doing it, because moles before dilution and after dilution are equal. You need to know this. It's not rote learning. I want you guys to be proper scientists, mini scientists. Mole before dilution and after dilution are equal. That's how we can equate C1 V1 with C2 V2. It's math, substitution. Okay. Okay, so C1 is what? 4.50, V1 is 125, and C2 I don't know, and V2 is what? What is the final volume? You guys have to tell me the final volume. What's V2? 30 plus 125, right? 30 plus 125. So that's 155 cm cube, right? Now, if you want, you can say, hey, this is in cm cube, this is in cm cube, let me convert it in dm cube. It doesn't really matter, because if I divide these both by 1000, what happens? 1000 cuts out with 1000. So it doesn't really matter. At the end of the day, these units are it would matter if one was in cm cube and the other was in dm cube. Then it would matter. Then you literally convert one of them, right? So it doesn't really matter. If you even convert this into dm cube like Raimar did, just divide it by 1000, divided by 1000, 1000 cuts out, right? So 4.50 times by 125 divided by 155. What's C2, sir? What's C2? Anji? 3.629. So 3.63 mole per dm cube. Done. That's it. Asan? Next question. What volume of water? Now you guys have it in your brains. What volume of water should Sir Suleiman add? Should I add as a lab assistant? Always think of yourself as a lab assistant, because that's what you are. No, I'm joking. Should I add? What volume of water should I add to sodium sulfate solution? और चलो H2SO4 कर लेते हैं. To 130 cm cube of H2SO4, 130 cm cube of 4 mole per dm cube of H2SO4 solution, to get a concentration of 0.1 mole per dm cube. And so now the questions are going to be designed in this way. They're not going to make diagrams for you like I make them. It's just the questions will be designed in plain English. So I've made diagrams for you. But yeah. Okay. Aisha has asked a good question. Aisha is saying, since C1, I haven't read it, but it must be good since it's long. Since C1 V1 and C2 V2 denote the moles, so aren't we just equating the moles before and after? No, no, no. Moles remain the same before and after, right? They're both equating moles, and yes, you can say this in mathematics. You could say this, absolutely you can. So my question is, how do we take this? Because moles are supposed to remain constants. Moles are supposed to remain constant, Aisha. What changes is the concentration that fluctuates, the volume fluctuates, Aisha. The moles, they'll fluctuate in such a way that you'll end up with the same moles. See, just like I've proved it to you right here in the first slide, all right here in the first slide. See, when we first figured out the moles, I said, hey, these moles would be equal to these moles. No matter the volume, no matter the concentration, the moles would remain the same. And how would they remain the same? This C2 and V2, they will fluctuate to make this equal to 0.02. They will fluctuate in such a manner that it would make it equal to 0.02. So effectively, yes, you're right. These two are changing. Concentration before and after are changing. The volume before and after is changing. But the moles remain the same. They will change in such a way to make the moles as the same as before, Aisha. Sir, this is exactly what that the equation concentration are being equated as the number of mole remain the same. So, okay, great stuff, Raima. Awesome. Proud of you. I'm sorry I couldn't get it before. 155. That's what Yumna is saying. Yumna, I hope you haven't made the mistake of the mistake of the mistake. Okay, so re sajna. Okay, Yumna is saying that's the old answer. Okay, let's see if you've calculated it correctly. Yaar, Raima, why are you giving me answers in DM cube? Okay, fine. If you want it in DM cube, it's fine. Chalo, great. Chalo. C1, I need to dilute it. C1 V1 equals C2 V2. Right? And if you shouldn't forget this formula, but if you ever get confused, you could first calculate the moles here, because the moles before and after are equal. So N equals CV, and then put the moles whatever you have, C and V. Right? So C1 V1 equals C2 V2. What is C1? 4. What is V1? 130. What is C2? I don't know. Oh, I know actually. It's 0.1. What is V2? I don't know. What do you get V2? I don't even have to divide by 1,000, because please understand, if you divide both by 1,000, they're both the same unit. So if you divide both by 1,000, thousands and thousands just cuts out. And it's good that you do it, that you're telling the examiner, hey, this is in mole per dm cube, so I can't use volume as cm cube. I'll have to divide by 1,000. Good stuff. Similarly here, this is in mole per dm cube. I shouldn't use the volume in cm cube, so I divided by 1,000 right here. Sorry. This isn't divided by 1,000. This should be divided by 1,000, right? I literally cut out. Okay, sir. Okay. Whoa, chili on the track. Somebody here for the snack. We just smell like pepper. Whoa, tree hugger, where you at? So the answer that we get is 5200 cm cube. I don't know how Raima got 5.07. Let's see. And sir, this is the total volume. Please, this is the total volume. Raima is absolutely right. Everybody's right. This is the final volume of the solution. V2 is actually what? It's the final volume of the solution. The final volume. I want to figure out how much water did I actually add. How much water should I add? So before it was 130. The final is 5200. So 5200 minus 130, sir. What do you get? Minus 130, 5070, and Raima is right, everybody's right, and we are done with moles and stoichiometry. Please watch all the videos which will be uploaded after this. This is lecture 51. Watch all the lectures that will be uploaded after this, and on Saturday, even if you haven't watched all the videos, you just need stoichiometry. You just need to know about stoichiometry in order to solve chapter number 6 questions, which is states of matter. So don't worry. We will still start off with states of matter even if you haven't completed moles and stoichiometry to its full extent. If you do, good for you. If you don't, and bad for you. Right? Still good for you. So we are officially done with all the advanced concept of A level. Other than this, the limiting and excess questions, the percentage yield questions, the percentage composition by mass questions, the empirical formula, the molecular formula, the titration questions, all would be added to your portal, and it's nothing new. It's the same as you've studied in O level. So the same O level stuff will be added to your portal, and we've already covered all the advanced concept of AS level moles. That's it. That's the only jump between O level and AS level. मजा आया? Enjoyed? सर आपने इतनी प्रैक्टिस करवानी थी? What do you mean?